Hi everyone, my name is Anushka Sawant and my project is about detection of malaria using cell images. So as we know, malaria is caused by female Anopheles mosquito, and when it bites us, it infects us with parasite. So it harms our cells. So in this project, we can detect the infected and uninfected cells using machine learning. So we have to make our computer understand what is the difference between these two. As you can see, there are purple parasites in our infected image. So we have to train our model to differentiate between the two. So how we'll do this? We'll do this with the help of VGG19 model. So in basics, it contains of some layers, and in every layer, uh, you can say the image is miniatured and the number of images or the number of screens are increased. So there contains convolution layers, fully connected layer, max pool layer, soft max layer. So this is the model, VG19 model. So what happens is initially we have an image. We'll have a cell image which will be size of 224 into 224. 3 is the RGB filter. So when it is passed through two convolution layer, convolution layer's filter size is 3 by 3, stride is 1. Stride means how many bytes it will leave after one cycle. And padding is that means the input is equal to output. So when it is passed through convolution layer, the input is equal to output. That means the size of you can say image is same 224 into 224. So yeah. But when it is passed through max pool layer, the image size is reduced. Every time it is passed through max pool layer, the image size is reduced, but the kernel size increases. So what happens in max pool layer is, I'll explain it with the help of this image. So here, as you can see, this small matrix is a miniatured version of this original matrix. It is 24 by 24 matrix. This is 12 by 12 matrix. So in max pooling, the filter size is 2 by 2. That means in every cycle, it will take 2 by 2 matrix. So here in the image, as you can see, there is a 2 by 2 matrix. So what happens is it will check for the highest number of no, it will check for the highest value in the four matrices, four matrix, or you can say four cells, and whatever the highest number is there, it will store it into the first cell of the miniature matrix. So this is what happens with max pooling, and stride is 2. That means after every cycle, the 2 bytes will be, you can say, left 2 bytes. It will leave 2 bytes in every cycle. So initially this was the matrix, it will leave 2 bytes, it will take the next matrix, it will again leave 2 bytes, next matrix. This goes on for every matrix. So this is what happens in maxpool. So therefore every time the size goes on, decreases. So this happens in VG19 model. Now I'll explain the coding part. So in the coding part, I have used Jupyter Notebook, and I have done the coding in Python. So initially, what we have to do is we have imported some libraries like NumPy for linear algebra, pandas for data processing, matplotlib for data visualization, Seaborn OS. These are all used for data visualization, PIL for image editing functions, and then I have used Kera's API. So I have imported some functions like image to array, because like our image will be converted into a NumPy array. So we need these functions. It will be like, you can see these are all image processing functions, because our cell images will go into a lot of processes during this whole training of model, and yeah, between input and output. So utilities, image generate, these are all data image, like image processing functions. Then these are the layers which we have to input. This is the our model VGG19. We have to import it as well. So next is, uh, we created the two objects, and we gave them, you can say, their directory or path file. So yeah, for parasitized and uninfected. Next we use the OpenCV. So in OpenCV, when we use OpenCV, it stores whatever our image is into, um, BGR numpire. So what happens is if we didn't use this function color BGR to RGB, it will show us somewhat like this. Here also we have used OpenCV, but we have not used our functions. So our image is stored like this initially, but if we use that function, it will show us the what you can say is original images. So here we have plotted a graph, but we have removed the axis, and we have just checked if it is getting the right path file or it is getting the right data set. The data set I have used here is I have downloaded it from Kaggle. It is not the original dataset because it had thousands of images. I just took the first 1000 images, and you can say my dataset is a bit short than that one. It is a really long dataset. So, yeah, this is we did this for infected ones, we did this for uninfected ones as well. So, the next is we gave them training and validation directory, which we'll need it during our training of our model. So initially we just gave them up to cell images, then we added parasitize and uninfected for both of them. Yeah. So next, we just found out the length, or you can say how many images are there for training for validation in both parasitized and uninfected data. So the total data is 966. So as I told you, I took the first 1000 images. So this is for training and validation. This is just for our purpose, knowledge purpose, you can say. So next is we initialize the batch size. So what is a batch size? In batch size, suppose we have 1000 bytes to read, and in every batch it will take, and we have given batch as 32. So in every batch it will take 32 bytes. So it will go up to 1000, and when those 1000 bytes are read, so it will be considered as one epoch. So here epoch we have given is 20. That means the whole model will run 20 times. It will train the whole model 20 times. So that is epoch. So next is we gave image width and height. Then these are some data processing functions we have used, like rescaling it, range. We have given class mode, batch size, image width for both training and validation. Next we have initialized our model. So we already gave it image height and width initially. So we have given weights, that is ImageNet. So these were pre-trained, like these are pre-trained weights, and it you can call it as a big data data set, or you can call it big database with computer vision research images. So the weights we have initialized as ImageNet. Then we have removed the top layer from our model. So why we did this? Because we'll only train the top layer of the model. We won't train the other layers of the model, or you can say other existing weights. So here, if we are we as we remove the top model, top layer, we don't need to train others. So here you can see trainable is equal to false. So we won't train the other layer. Then we'll flatten every other layer, because we like those layers are ready to use. So the last layer, we'll again, you can say, initialize the last layer, and we will use the activation function as sigmoid, because we have um, like we have two outputs, 0 and 1. If it is 0, that means it's infected, and 1 if it is not infected. So here our model is complete. We have initialized it, we have given its last layer. So this is what it looks like. This is a summary of our model. Whatever layers are there present in there, this is our dense layer which we added. So here we can conclude that yes, our model is successful. Then we you can say initialize some optimization method, and we initialized accuracy and precision because we'll need it. It shows it after the training of the model. So yeah, the next is training of a model. It took around 45 minutes for me for 20 epochs. And yeah, after this our model was trained, we can it is ready to use. And this is for our you can say curiosity purpose. You can say we plot our graph, And here you can see that with the increase of epochs, or you can see with the increase of cycle, accuracy increases, and as well with the increase of epochs, loss is also decreasing. So accuracy increases, loss decreases. That means the model is a success. So next we save the model, and then we tested it for one image. Like we randomly gave it a path size of one image. Right now until this part we haven't created any front end, so we need to test if our model is up and running. So here as you can see we just gave it an uninfected path, so it should show us, yeah, this is the image, and it is showing one is for not infected. So yes, this model is running and our output is correct. So next part is our front end. I've used Flask and HTML for all these, so I'll just show you the front end. So this is my front end. I have to choose any image which I want to test. So first let's check for uninfected ones. You can use any image you want from from internet or anything. So yeah, you can see the patient is not infected by malaria. So I'll just check for parasitized if it works. Yeah, as you can see the patient is infected by malaria. So this was the front end. I have told you about the back end, my data set. So yeah, this is an end-to-end project made by me, and yes, thank you.